All right, we're gonna go ahead and get started now. So, a couple things. Did everyone get the email that I sent the other day
Yes, sir.
in regards to the extra credit? Yeah. So to reiterate, let me just I'll just open this again. So you can read all of this in the email that I sent, but I was basically saying that I was giving you guys an extra credit opportunity because you see, I'm a member of Lumos PASO, which is the Filipino American Student Organization, and for the past couple months we've been uh, we've been working on this performance that we're gonna stream virtually on April 17th, and I wanted this to be like an educational experience because of the recent news on the media regarding hate attacks towards Asian minorities. Um, I hope that this performance will give a new perspective on like minority groups and basically prevent ignorance and more hateful acts in the future. So the details are in the email, but if you want to receive extra credit for watching this event, you have to first use this link to RSVP to the event, and you must watch the live stream on April 17th and April 24th because there's two acts, right? The first one's going to be on April 17th at 7:30 p.m. and the act 2 is going to be on April 24th at 7:30 p.m. And then after you've watched that, I would like you to write a very brief response stating your thoughts, your opinions on the performance, and what you took away from it. And then email it to me at my Coyote email with your name and student ID written somewhere in your response, and then use this template as your subject line. And if you get that to me before the end of the term, you'll be getting extra credits. Now, how much extra credit I'm going to give you, I'm not quite sure yet. Because thing is, I'm not quite sure how to like change the grading in the Zybooks, but I'm pretty sure I'll figure it out before the end of the term. But is there any questions in regards to this announcement? No. All right. Well, for those of you that do intend to watch this event, yeah, I actually did play a role, and I actually did do a dance in this performance. So I hope you guys enjoy it. I hope you guys find it entertaining. But enough of that. The next order of business is the week 10 sections. So for those of you who already finished the sections, um, was there any parts that you feel like we need to go over? It was pretty easy. Okay, that's what I like to hear. Okay. So so just to be clear, there's only 5 sections this week, so it wasn't too bad, I hope. So is there any parts that anyone had trouble on? We can look at it before we dive into the 2 labs. Value Moore says in the chat, also, professor said he would upload homework on Thursday. Oh, okay. So would you guys want to look at homework on Thursday again? Yeah. Perfect. So we'll have a plan for our next meeting time on Thursday. But anyways, without any further ado, we can go right into the labs. I actually unlocked 2 of them for you, and they're pretty brief. Now, Now, because of how brief these two labs are, what I would like to do, or what I hope to do, is that if we have enough time after doing these two, maybe I could take like a couple minutes to talk about classes, because I was looking at these sections myself, and I had a feeling that some of you might feel lost and confused because you're using classes even though you haven't learned classes yet. And I don't think Professor Amir has taught classes to you yet, has he? Yeah. Has he taught classes to you yet? Well, classes aren't really that difficult, but it does take some, I do need to take some time to explain it. Otherwise you might get confused. All right. All right. So no one's responding to my question. So can I take it he hasn't taught classes to you yet?
He hasn't gone over it now.
Okay. So, all right. So I'll try to make that the goal today. If we speed through these two labs, I'm going to teach classes to you. Okay. So the first one we're going to look at is 10.6 inventory. Okay. So 10.6 says inventory linked list insert at the front of the list. Okay. So given our main function, it says define at and insert at front member function of the inventory node class that inserts items at the front of the linked list after the dummy head node. So if the input is this, for plates 100, spoons 200, cups 150, forks 200. Jose Garcia says, sorry for being late, my internet died. That's okay. We didn't do anything yet. I was just talking about the extra credit opportunity, and I was just saying that after these two labs, I might take a moment to talk about classes. Anyways, it says,
What was the extra credit opportunity?
oh, I sent an email about it the other day. Did you get a chance to look at it?
Okay, I'll look at it.
Okay. So so this so the inventory node class has, well, let's take a moment to look at it. It has two private members excluding the pointer variable, right? It's a string called item, which is saying what the item is, and then the second one is an int number of items. So this is basically saying we have 100 plates, we have 200 spoons, we have 150 cups, we have 200 forks, right? Now, let's take a look at the int main and try to figure out what's going on here. Okay, so this is the main function, and we're gonna, of course, we're including the inventory node dot h header file, right? Because this gives us access to the inventory node class, which defines what inventory node is, right? Because we're using data types that are of type inventory node. Do you see that? Anyways, so it defines an int called count, an int called, this is a temporary variable for the number of items, and this is a temporary string variable that will hold the whatever the name of the item is, right? Next, we define two data types of type inventory node, right? The first one is a pointer variable called head node, and we set it equal to new inventory node, right? The second variable is another pointer variable called current node, right? So the first thing we got to do is see in the number of things that we're going to collect, right? So we see in count. If the input is 4, it'll take 4 as count, right? And after we retrieve what count is equal to, this for loop will occur. And this is the thing that's inserting these nodes into the linked list, right? So each time this for loop iterates, we will see in an item. So for example, plates, right? And then we will see in the number of items, which is going to be 100, right? And it would do this 4 times, right? Because we have 4 objects here, right? Now, it's saying current node equals new inventory node. And this line of code here calls the constructor for inventory node. We can take a second to look at that if you want. So when this is called by the main function, what this is actually doing is that setting current node equal to, let's find the constructor that accepts those 2 parameters, okay? So you see we have 2 constructors here. One that accepts 3 parameters and one that accepts 2. If you look at the main function, it looks like we're calling the constructor that accepts 2 parameters, right? So what that means when line 8, when the code in line 18 is used, it's going to refer to this constructor here. Not this one, right? Because classes can have multiple constructors. Maybe I'll talk about that more if we finish this early. But anyways, so it accepts 2 parameters. One of them is the string item initializer, int number of items initializer. So we'll say that this referring to the item that we're looking at. The member item called item is going to be equal to whatever we pass this item in ints. And then number of items is the other private variable, right? It's going to be set equal to whatever variable we pass as number of items in ints. Okay. So if you go back to the main function, if the as I said, this iterates 4 times. So we'll say we'll get plates 100, spoons 200, so on and so forth. So if item was plates and num items was 200, this, I'll make this a little larger so you can see it. This will become plates. This will become 200. And then it's passed to this constructor here, where we set this brand new inventory node, because it is a new inventory node. We're creating a new inventory node, and its item is equal to plates, and its number of items is equal to 200, right? And then the next thing we're doing is we're setting the pointer variable equal to null, right? Because it doesn't have anything to point to yet. It's a new node, right? Feel free to stop me if you have any questions. But anyways, so it'll do that 4 times. But then we got this. We say that current node, we're calling the insert at front function for the current node that we created in this line, okay? Now, if you go back to the instructions, it says that define an insert at front member function in the inventory node class that inserts items at the front of the linked list after the dummy head node. So, so if you actually went back to inventory node.h, you'll see that the insert at front function is not defined yet. That's the function that we have to define. Okay. So we have to do this in order for this code to work, because we are saying, yeah. So head node is the first item, and then current node is the next item. But the way we want to do this is that we want to I think a visual might help. So say this is the head node, right? And put this aside. Yeah. Actually, so they say this is the head node, right? It's currently pointing to nothing, right? It's pointing to null, right? But when we perform this line of code, where after we create the current node, we don't want to put this node at the end of the linked list the same way we were doing before, right? The instructions here say that we want to put it, we want to insert items at the front. Yeah, so what we want to do is after in the first iteration, when we get plates 100, this what we want to do is say this was plates 100. What we want to do is we want to make this node, we want to put it right in front of the head node like that. So that's doing this. And we do that using the insert at front function that we're about to define, right? And then when we retrieve, when the next iteration of the for loop happens, we got spoons 200. So and then we got 2 more nodes as well. I'll just do this. So that there's room. And the third iterations is going to be cups 150. And then the fourth iteration is going to be forks 200. Like that, right? And then so after this, these lines of code here print the linked list that we made, right? So basically what this says is that current node equals head node dot get next. And while current node is not equal to null, we will print what we got. And when we print, it'll say forks 200, cups 150, spoons 200, plates 100. And that's actually the backwards order of the way we receive it, because we're not inserting it. We're not inserting these nodes at the end. We're inserting them in the beginning. So it would read like this, like this, right? Forks, cups, spoons. Yeah. All right, so now that we understand what we gotta do, all that's left now is that we gotta write the code that does this. So there's only one function we have to make, and that's the insert at front method. Okay. So how are we gonna write this? How can we have this, the next node, be inserted at the front of the list? Well, let's look back at main.cpp. So it looks like it's insert at front requires two parameters, right? One being the head node and the second one being the current node. And what we're trying to do is put make current node in front of head node, right? So here's what I think we gotta do. Now I would argue that this insert at front function that we're gonna write here, I would argue that is going to be a void function, right? Now the reason why I say it's a void function is because it's not returning any sort of data. It's just performing an operation, right? Would you guys agree with that? Yeah, no. Anyways, so the next thing we got to do is we already see that it's the insert at front function needs to accept two parameters, right? Both of them have to be of type inventory node, right? So I'm going to go back here to my definition. I'm going to say the first argument needs to be of type in. The second one also needs to be of type inventory node. Okay. But I do need to give these variables names. What do you guys want to name it? I think the simplest names I can come up with is node A and node B.
Oh, I need to be capitalized, I think. In the
What needs to be
inventory node.
capitalized?
The inventory node.
Oh yeah, you're right. No, I'm so used to typing in camel case. Like I didn't even notice that. Thank you for capturing that.
Yeah, I think the book uses capital letters for objects.
So do you want to call this uppercase A and uppercase B? It doesn't really matter, but anyways, and again, what we're actually doing is we're getting the addresses of these nodes, not the nodes themselves. So what I actually got to do is put the dereferencing operator here, indicating that these are pointer variables. Forgot to mention that. Okay. So what now? Well, I'm trying to. So I got a head node and I got a current node, right? What I'm trying to do is make current node the new head and have it point to have head node be the next node, right? So I say the nice thing about this function is that you see what we're trying to do is make B point to A. And this header file actually already contains a function that gives us the power to change what a node is currently pointing to. Do you guys see it? The function that allows us to get the next node.
Is it the get next function?
Yep, it's a get next function. So here's what I think I gotta do. I say, because I named the current node B, I think I have to say B get next or is it? Oh wait, I actually wouldn't use this. I would actually use this actually. So I would say B pointing to next node ref. So next node. All right. I have to set this equal to A pointing to next node ref. Right. And then I say A pointing to next node. So do we see what's going on in these two lines of code? So
You have a typo, line 39.
oh, thanks. Next node ref. So I actually wouldn't use the get next function. I can actually just use this. So let's try to understand what's happening here. So maybe let me open a new thing so I can draw this out for you. So let's say that I had my head node, yes. And I called my head node A, right? A is my head node and B is my current node. So and I will say that this is my current node, which I called B, right? So this head node A is pointing at something, right? I don't know what it's pointing to. It could be pointing to a null, meaning that there's no other nodes in the list, or it could be pointing to another node, right? I don't know what it's pointing to, but whatever it's pointing to, what I'm basically saying is that whatever it is here that I'm pointing to, I'll make it bigger. It could be null, it could be another node. I'm going to set the next node ref, which is the pointer variable to the next item. I'm going to set next node ref of B equal to the next node ref of A. So what I'm saying is I'm saying that whatever A is pointing to, B is pointing to it as well, right? That's what I accomplished with this line of code and line 38. And then I said, A next node ref equals B. What that basically means is I'm changing the value of this. So A, I don't want you to point to what you're pointing to anymore. I actually want you to point to B now. So basically what I'm trying to do is I'm going to get rid of that. And I'm going to say, hey, node A, I'm going to make you point to B. That's how we do it. And that's actually how we do the switch and insert the node B to the, yeah. But does this make sense, how this works? We can run it now to see if it works. So, and I believe we didn't change the main function at all, right? Yeah. The instructions don't ask us to change the main function. So I think let's run this to see if it does it. No?
I don't think insert at front works, unfortunately.
What did we do? Doesn't like this. Oh, I see. So in the main.cpp, it looks like I misspelled insert at front. It's supposed to be uppercase I, not lowercase I. See, I'm so used to typing in camel case. That's why. Insert at front. All right. Maybe now this will work. Valerie Morris says, where did you guys define insert at front? We inserted it underneath this comment here, because this comment says to define an inserted function, then insert a node at the front of the linked list, like that. This is where we wrote it. Does that answer your question, Valerie Mora?
Yes.
Okay. So maybe let's try it one more time. There we go. So we said that there's 4 items to insert, and then here are the 4 items we read, and then of course we read them back. We read them backwards because we were inserting the nodes at the front of the list instead of the back. Does this lab make sense to everyone? I accidentally put void : instead of just void. Yeah, that happens sometimes. Okay.
Wait, so what does this solution look like again?
Huh? I'm sorry?
Yeah, so you use the use insert. No, you use the next node ref variable, right?
Yeah, I use the next variable. I actually didn't need to use this. I for a second I thought I had to, but I realized no, it's this. I just got to use this. But okay, so that's that lab. The only code that you need to put is this code here. Okay. Now, here's the thing. We have 15 minutes left in this meeting. So I have a question for you guys, because we did use a good chunk of time to do this lab, and I know it was I only need to give you these 5 lines of code, but I did have to give you some like understanding before you actually had to go and do it, right? So here's my question for you guys. Would you like it if I just give you this lab 10.6, the one we did, and get rid of lab 10.7 and just go straight to talking about classes? Because we do have 15 minutes left, and I think that talking about classes is a better use of our time than doing the labs. What do you guys say? Well, I'm asking you guys if you guys just don't want to do lab 10.7 anymore. Like, it's visible right now. I'll just hide it so you don't have to do it anymore. And then I can spend the rest of the time talking about classes. Because here's the thing. The reason I'm asking this to you guys is because, like, in the couple hours before I started this session, I was looking at these labs and the following labs too. Well, not these ones, but the ones later. These labs are really heavy with classes now. Like, this is a class, and this has classes too. And I just don't feel right making you guys do these labs when you guys haven't talked about classes. Like look at this one. Like, this one's really heavy with classes, right? Like, look at that. Yeah, I can't make you guys do that.
Yeah, I feel like now with the header file and that kind of stuff, it's kind of become not like difficult per se, but it's kind of confusing on where to go. Do I need to do this in the main, or do I need to do this in the header file? So at least for me, it just feels kind of confusing.
Okay. So is everyone in agreement that I'll spend the rest of the meeting talking to you guys about classes?
Okay.
All right, super.
Yeah,
right.
honestly, I think the book goes kind of out of order sometimes. Like back when we were working on functions, it was trying to talk about functions on vectors before actually teaching vector basics. And it's kind of doing the same thing here with pointers and classes.
Yeah, you're right. Well, I can see why they wanted to put linked lists in a class. And pointers are really used for linked lists, but you can't really talk about linked lists without going into classes. But that's fine. It won't, I don't imagine it'll take that long to talk about classes. So I'm going to call this project Intro to Class. Now, I think you guys are going to really like classes, because when you guys learn how to utilize classes, you're going to find that they're very powerful, because if you got like really complicated programs, classes are a good way of like segmenting your code so the complicated becomes less complicated. Well, you'll see when I give you this demonstration. Okay, so I'm gonna make a main.cpp. All right, let's make this big enough so you guys can see. Include IO stream. And main. Okay, so here's what I'm gonna do. What's a really simple example that I can make a class of? Let's say that you know, in the last class I taught, I made a class called person type that stores the information of individual people so that you can put it in a school database. So maybe I'll use that as an example. So here's what I'm going to do. I don't know how code blocks allows you to add header files, but for me, for Visual Studio, if I wanted to add a header file, I would right click on source files, hover over add, click new item. Now I would choose a header file, not CPP file. And then I would give this header file a name. But it's good practice to name your header files after the name of the class that you're trying to write. So I'm gonna call this person.h because, or actually person class, that was probably all right. So I'm gonna call this person class.h, okay? So I'm gonna say add, okay? So I think I need to look at my old lecture notes to really show you guys how to do classes. So I can just find that real fast. Yeah. So this is one of my PowerPoints from when the old classes I taught. So this is the syntax for a class, right? You use the keyword class, you say the identifier, and then you have two sections inside squiggly brackets. One of them is called public, the other one's called private, okay? So I'm gonna say class. Now I'm gonna call this class person class, right? Because that's why I named my header file. Person. And I'm gonna have two sections, one called private and one called public, like that. Now, so a class always has member variables and member functions, right? You could sort them in either public or private. Now, good programming practice is to put variables under private and then put functions in public. That's a rule of thumb. Now, you might be wondering what's the difference between the two. I'll get to that in a little bit, but let's declare some variables. So if I was writing this for a database program, what's something that a person might have? They might have a string, first name, like that. Why are you in error? I think I gotta. Why are you undefined? I just included string, but it didn't like it. There we go. So include IOStream. Well, I would only include IOStream if I was C in and C outing things. Well, you know what? I might do that. So yeah, I'll include it. Include IOStream. It doesn't hurt, right? So I say that so a person might have a first name. They could also have a last name too. So I'll say string last name, like that. And what's another thing that a person has? Probably age, right? So I'm gonna say int age. Right? So now I'm going to have this here. Now, I said before that I would have variable. It's a good idea to have data variables in private. But just for the time being, I'm going to show you what happens if I put it under public instead. So I'm actually going to move this here instead. Okay. All right. So now my person class has 3 variables: first name, last name, and age. Right. I could actually, even though this looks unfinished right now, I could actually start using this class now if I wanted to. So if I said, well, in order for me to use it, my int main needs to include person class.age, right? Now, do you notice that when I'm including files that aren't libraries, and these are files that I'm writing myself, I have to put them in double quotes instead of chevrons? Keep that in mind. So what happens now is that this class called person class, it's actually now a new data type that I can use, right? So if I said, like, I can declare a data of person class the same way I would declare int variables. So if I said int a equals 7, where this is the type and this is the name, I can actually say person class person, right? Now I can actually set now person A is of type person class, which has a first name, last name, and age, right? So if I wanted to change person A's first name, last name, and age, the way I would do that is using what's called the dot operator, right? So I can say person A. Now, if I say dots, it gives me a list of options, right? I have age, first name, and last name. So if I said first name equals Bob, like that, and I said person A dot last name equals Jones, and I said person A dot age equals 25, maybe. By doing this, I actually set the variables for person A, right? Now, what if I wanted to see out person A's info? Like say, now that's actually quite easy. So the nice thing about classes is that the members of a class include variables, but they can also include functions. So let's say I wanted to write a print function that outputs all 3 variables. Like, check this out. So let's say I'm going to make a new function here that prints the variables. And I can name these functions anything I want. But for the sake of this example, I think I'm going to call this function print. And this is a function that accepts no parameters, right? And I actually want you to be of type void because it's not retrieving data. It's just outing information. So here's what I'm going to do. I have this function prototype here. I'm going to define this function now. So I'm going to go over here underneath the person class, and I'm going to start defining it. Now, this would actually throw an error here if I did it like this. What I need to do first is indicate that this function is a member of person class. Otherwise, the compiler will think that this is a function that's standing alone by itself, separate from the person class. And the way I do that is say, I'll take this here and put colon colon in front of it. So the double colon is the it's the member access specifier, I think. Let me look at my old PowerPoint and try to remember what it's called. The double colon. No, it's not there. Oh, it's a scope resolution operator. So to indicate that this function is a member of person class, I use the scope resolution operator to say that it is. Now, let's say I wanted to this function to see out the contents of these variables, right? I want to say, let's say I wanted to say Bob Jones is 25 years old. So the way I would do that is I would say see out first name space last name space is age years old. Right? So after I do this, I can actually call this function now by using the dot operator the same way I did before. So I could say person A dots. Now, do you notice before that I had 3 options before, them being age, name, first name, and last name? Those were the data, but this time I'm calling a function, right? And this function is now an option on the list because it used to be that this class had 3 members before, and these variables. But now I added a 4th member, and this is a member function, right? So what happens as a result of this, and because this is a function, I do need to put open close parentheses. What happens as a result of this is that this will say Bob Jones is 25. Yeah, Bob Jones is 25 years old. So if you guys want to see this in like debugging, like maybe I'll dock this over here and put this over here. I can step through the lines of code. So I declared a variable called person A that's a type person class. I set its name, first name member variable to Bob, last name member variable to Jones. Age equal to 25, and then I say print person. What this does is that it goes directly to the person class.h and then prints this line, right? So after it does that, I'll return to the main.cpp, and that's what it does. So classes are just really a good way of like organizing your code, right? Yeah, I know I'm over time here, but I hope that this was a good, a worthwhile look into what classes are. I know I haven't discussed what the difference between public and privates, but maybe I can do that in our next meeting. I don't know. Well, what do you guys think? Was this a worthwhile lesson for you guys?
I think so.
Yeah. Okay. All right. Yeah, like there's a lot about classes that I still didn't go over yet. I didn't tell you the difference between public and private. I also didn't show you what a constructor does. I was hoping that if we had more time, I could actually make a constructor for this, but yeah, we are out of time right now.
Wait, so are you allowed to define a function in a header file?
Yeah. You could, if that function is a member of the class. Print person is a member of person class, as you can see by the scope resolution operator here. Well, you know what? You know what, guys? I actually had an old lecture video before, because I did teach another class before this one last semester, where I talked all about classes. Now, I'm not gonna make you guys watch it, but if you guys did want to learn more about classes, I would give you the video if you want me to. You guys want that? So, so I talked about classes in this video here. Lecture video 6, and again in lecture video 7. I believe in this one I talked about the basics of classes. Yeah, I don't start talking about classes until way over here, 40 minutes in, and then I talk about classes some more here. This entire video was all about constructors. Now, like I said, I'm not gonna force you guys to watch those videos because that's not relevant to this class. But if you guys did want to learn more about classes, those are the 2 videos I would point you towards. But anyways, yeah, I think this person class program that I wrote, I think I'll save it for if we have time in our next meeting, after we look at Professor Amir's homework. But aside from that, I think we're good to wrap up this meeting. What do you guys say?
Oh, I just realized something. What if maybe for the next meeting or something, we can do something with Professor Mirror homework and then add on to it with, I don't know, classes and other stuff, so we can go on that. So we can get like
Does his next homework discuss classes?
not sure, but I mean, like, just like it's like our own little thing, just because it's as if we use it as a base work, and then maybe we can figure out ways to add onto it. Like, you know, like a real life situation where you expand a project or a program.
Right. Oh, maybe. We could try to. Well, we would have to look at what his homework looks like.
Sure.
But if I wanted to expand on that person class that I made just now, I think the next thing I would do is write a constructor, and then maybe I could probably think of other variables to put to. Maybe I can make a Boolean variable that returns true or false if the person is a senior, like if they were 65 or older, that kind of thing. But yeah, like I can expand on this later, and if we have time in our next meeting. But yeah, I hope I did a good job of teaching you guys today. But unless anyone has any other questions, I could just wrap this up and say I'll see you guys Thursday. What do you guys say? We good? Awesome. All right. So yeah, I'll see you guys Thursday. Hopefully we'll look at the homework, and then hopefully if there's time, we'll continue talking about classes. So see you guys.